live, going live, YouTube right now. YouTube live active. So hi guys, good afternoon. Good afternoon, Prasad Vaishnavi, and waiting for the others to join. I hope others will join soon. So you are gonna test it, yeah? Is there any test going on? Some sorry, I think so. There were some random arrangements. Okay, Monday you have UT. Which subject? Yeah, subject. You have any subject like is it physics or something like that? So physics or maths. Okay, right, Priyanka. Good afternoon. So guys, yeah, in today's class we'll be discussing the last part of it's the last part of sorry, current electricity. This is nothing but the electric devices. So we have learned about KVL, KCL, Ohm's law, and other laws so far, and we got very less time. I mean, we discussed very few of the problems. So we have plenty more to discuss. Actually, about the problems alone, there are variety of problems to discuss. So we are seeking permission from our higher management to conduct extra classes, and if that's possible, that will be done. Or let's see. I think that's the one thing which is possible for now because you guys have your exams also, right? Hi Bhargav, good afternoon. Uh, so there is your keyboard 2, sorry, keyboard 1, first exam of keyboard maybe going to start by 21st, for which we have to let go of our classes maybe much earlier, but no, so we may continue to conduct the classes for some time since we have huge learning in syllabus. So yeah, we'll be completing this chapter. That is the third chapter will be done. 3 chapters is done for you guys. The first one is electrostatics, then capacitors. This chapter will be done maximum by today. I think we can complete maximum of galvanometer and its conversions and meter bridge and Wheatstone bridge. So next we have potentiometer. So for potentiometer, you need some extra things. Like okay, I hope potentiometer is done at your end. Is potentiometer done at your schools? It's a necessary thing which should be done. So I think yeah, potentiometer might have been done. Okay, let's see. Sunday classes about Sunday classes, Hari Prasad, we need to discuss. So it will be discussed, decided, and will be informed before Sunday classes are happening. If classes are not happening, what can we do? In one of the classes, I would ask or the end of say, okay, right. So there is Vinay's class on Saturday evening, right? By Saturday evening, we can inform you. So we can try to inform you by Saturday evening in Grace's class. So if there is class, we will inform in all Telegram groups and also we should use in YouTube also we should use in WhatsApp. WhatsApp will be informed. Good. So guys, please give the technical check. So there are. So yeah, I know other students are not coming. Okay, everyone has UT. And here we have only 4 students in this Zoom. But unfortunately, we can't cancel any of our classes. So, yeah, then everybody's test timings are different. That's the issue. Otherwise, we would have asked our management to check and cancel classes on some 2 days. Okay, is my voice low, guys? Guys, is my voice very low? Please let me know if my voice is very low. Guys, is my voice very low? Someone please reply in the chat box. ನನ್ನ ಸೌಂಡ್ ವಾಯ್ಸ್ ತುಂಬಾ ಕಡಿಮೆ ಕೇಳ್ತಿದ್ಯಾ? Guys, someone please respond. Is my voice very low? Hi, hi, check, check. Okay, just a moment, guys. I don't know why this is happening every day. Maybe my network connection. So my network connection is also good. Network strength is good. Guys, yes, yes, yes. Can you hear my voice now clearly? Is my voice audible and clear? Um, Chinmay Prajwal, Priyanka Prajwal, Rashika Vaishnavi, someone please confirm. Is my voice audible clearly, guys? Yes, okay, cool. So there is no volume or there is nothing like that, right? My voice is clear. That's cool. Cool. Thank you, guys. So let's start our class. We have a lot to discuss and we have a lot to complete. So I'm going to end your poll and we'll start our class now. So yes, we will be discussing about electrical devices in today's class. In the previous class, we discussed about KVL, KCL, and combination of uh, our cells. So in today's class, we will be discussing about galvanometer. So what is a galvanometer? So how does galvanometer work? Then the construction. So guys, yes, there is a good announcement about JEE mains. We will discuss about that. I mean, in last few minutes, I will discuss about the updates regarding JEE mains. Okay, so please wait patiently. Okay, so in today's class we'll be discussing about galvanometer, conversion of galvanometer to ammeter, then conversion of galvanometer to voltmeter. Then we'll be discussing about Wheatstone bridge and meter bridge. So potentiometer, if time permits, we'll start. But I think by completion of this, we would by discussion by the end of meter bridge, maybe I am expecting like okay, we won't get time. But if we get time, we can start with potentiometer. But potentiometer itself has two applications. If you remember, guys, potentiometer has two applications. It's a very important topic, both for CBSE as well as for any of your competitive exams. So that will be done in detail. So we require one separate class for potentiometer, I guess. No? So I'm planning to go with galvanometer, conversion of galvanometer to ammeter and voltmeter, Wheatstone bridge and meter bridge. Okay. Okay. Good evening, all. So welcome to class. So guys, yes, in yesterday's class, okay, in previous class, we discussed about galvanometer. So yeah, I think I gave a brief introduction. Did I? Okay, maybe it's okay. Never mind. So what is a galvanometer, guys? So we see that there's a galvanometer. So what is a galvanometer? What do you think a galvanometer is? Please be try to be active and try to respond, guys. Okay, if yeah, please try to respond by giving answers. Your answers, like if you respond more, I can be active more. If you guys are active, we can also teach actively and we can participate. So we can do it's like give and take, right? So please be active, guys. Come on. So yeah, let's start. So what's a galvanometer, guys? Galvanometer andre ಏನು? Yes. So as the statement says, a galvanometer is a device. So this is a galvanometer which you see here. This one. So this device which we see here is a galvanometer. What happens in this device is yes, it detects the current. Correct, guys. Cool. So a galvanometer is a device which detects the current or flow of current. So a galvanometer is a current measuring and a current sensing device. Why? It measures the amount of current. It measures the amount of current. It checks the presence of current. So what are the functions of galvanometer? A galvanometer can measure. Okay. So a galvanometer can measure the amount of current Okay, measure the current. It can sense the current in a device. So it's a current sensing device, it's a current measuring device. Say if we have any circuit, in this circuit, if I want to check, so if I connect this to a battery, I don't know whether this battery is a fresh battery, a new battery or not. So I assume there exists a current. If the resistances are, then I know the value of current from Ohm's law. What is it? I is equals to V by R, right? Okay, I is equals to V by R. I know this. So I don't know whether the current is actually flowing. So I calculate the say voltage is 10 volts and resistor is 10 kilo ohms. Then the current I will be 10 volts upon 10 kilo ohms. That is 1 milliamperes, right? So current would be 1 milliamperes. So when I calculate this, I can calculate using my Ohm's law. So once I calculate using Ohm's law, if I can I check this in action? Yes, I can. So to check this in action, I may connect a galvanometer here. So when I connect a galvanometer, what happens is this galvanometer, say I'll connect the one end of the galvanometer, say how to connect this. So always, guys, tell me, how should I connect a galvanometer? Is it across or is it through? Should I connect it in series or should I connect it in parallel? Yes, always, guys, please remember this. Please make a note of it. All current measurements is done in series only. Okay. Why? Why? All current measurements are done in series. All voltage measurements are always done in parallel because we know that the current remains constant in a series circuit and voltage remains constant in a parallel circuit. That's the reason we are going to do this. Please remember, always whenever we are going to connect an ammeter or a galvanometer, we connect it in series only. Okay, we connect it in series only. Whereas when we are connecting a voltmeter, we will connect it in parallel. So it's always connected in okay. So parallel also is given in English. In English, they call it as across. A voltmeter is connected across. Across means parallel. Okay. So please remember these lines. So yeah, coming to this, the galvanometer has a current sensing, current measuring device. It measures the current. So when the current flows from say positive coil to negative coil, what happens? So what do you think happens? When a current flows from positive of this coil to the negative of the coil, what should happen? Yes, correct, Devgirani, Priyanka. So yes, it detects the current, right? It detects the current, and the needle which is at zero, this needle which is at zero, tilts. Okay, it will either bend on towards the right. So either my needle bends towards the right or it bends towards the left. Why? So whenever there is presence of current, say if there is presence of current, if I connect a positive point here and a negative point here, my needle tilts towards the positive, saying that there is some positive current. So if I consider everything towards right is positive, so this galvanometer tilts to, I mean, the needle of this galvanometer moves to right. Okay. Similarly, if the current is in opposite direction, it will tilt to left. So this way, my galvanometer shows the direction of current also, and it also measures up to a rated value. So here, this galvanometer is rated in the order of milliamps. So this galvanometer can measure up to a maximum of 60 milliamps, but in actual, it measures only 0 to 30 in half scale, right? So the galvanometer is calibrated. So the measuring scale of galvanometer is called as calibration. Okay, calibration, I think you guys know what is calibration. Guys, I hope you guys know what is calibration. Calibration is to measure, to check the correctness or to check the accuracy of any measuring device. Right. So this galvanometer is calibrated up to 30 milliamps only. So whenever there is presence of positive 30 milliamps, so if positive current flows from here to here, this galvanometer deflects towards right. If a negative current flows in place of this, if a negative current flows, and or if positive is connected here and negative is connected here, okay, in the reverse direction, then the galvanometer shows reflection in opposite direction. This is the way it shows, and the circuit symbol, it shows the current direction and also measures the amount of current. Okay, and the circuit symbol for galvanometer is this. Okay, so it's a encircled G. Okay, it's a circle with a G. So yeah, there won't be, actually in practice there won't be any polarity like plus and minus. We can connect either plus to this or minus to this, vice versa. Okay, so this is a galvanometer. Now galvanometer, we know it as current sensing device. Now, is it useful everywhere? Is it useful everywhere? So can I measure only? So would I get always a current measurement of only 30 milliamps, guys? Will I get, so what is our home? In our homes we have okay, how many of your homes as a meter? I think all of you might have seen your home house meter, right? In your house there is a meter to measure current, voltage, and also how much power is consumed. Have you ever checked that, guys? Have you checked that? So have you wondered how it works or why it works? I mean, how it actually happens? So hey, have you guys checked that how the energy meter in your home shows? So there was, if you remember, sometime earlier, I don't know, maybe in Bangalore now it is changed. In Bangalore, I think most of the meters are digitalized. I think even in some villages also it's digitalized. But before that, there was some meter. I mean, there was a daba in front of your house. There is a black box with some readings. Have you seen that? Respond. So if you have seen that, and beside that, in very old machines or in very old in some industries or in some houses, they also give an total connection. Say there will be a meter like this, so there will be a small screw-like structure and some readings and an arrow which shows like this. It always measures points at some reading, always maybe 5, and there will be a capital A written on this. Have you seen such machine in your grid? Yes, there is a disk inside it. Yes, yeah. So you might have seen an energy meter like this, which has some numbers. So and now it's digitalized, but earlier there was a disk inside this, and this disk used to rotate. So this had a red mark here, small red mark, and this disk rotates, and this shows how much energy is consumed. And beside this disk, there will be a meter like this, and one more meter like this with capital B and capital A, and some symbol like this. Hmm. Exactly, in your borewell box, yeah, in your pump set device. Maybe people who are in villages might have seen this. So in your pump set device, there is such voltage. So there are some several markings, and this has a needle which always points at some voltage, and should be somewhere around 415. I think this is the one, and there will be this. So what are these? Guys? What is this? What is this? And what is this? Have you seen this? What do you think this is? What do you think this meter is? So in your, I think in your homes, your parents or grandparents would say meter, not a meter. They'll just call it meter. So this meter is nothing but an energy meter. Okay, energy meter or watt meter. WATT, watt meter. So this is measures how much energy is consumed, how much electrical energy is consumed. So this meter, which has A in it, this is called as an ammeter, right? So this is called an ammeter. And say there are two types of ammeter. One shows a sine wave like this, one shows a dash like this. So sine wave represents your AC signal. It's a meter to measure AC current. So a dash just shows that it's DC. And some shows this dash and dot dot dot. This also shows DC, which is variable. Okay. Next, yeah, this capital B was an old meter. Okay. So we'll study how an ammeter, how an voltmeter, and how an okay. We'll only study about how an ammeter and how an voltmeter is constructed using a galvanometer. Now here in this case, I have a circuit. I have a circuit where I have connected some potential across this circuit. So it has a series resistance R, and this is connected across a voltmeter. Sorry, across a voltage source. So now this voltage source is connected, and I know there is some current flowing through this. Now this current is nothing but, yeah, I. Right, this is the current I. Now, how is it calculated? Using Ohm's law. Using Ohm's law, we can calculate this current as I is equals to V by R. Now this is my calculated current, right? Now I want to measure the actual current flowing through this. What should I do? Yes, I want to measure the actual current flowing through this. I know I calculated theoretical value. So I got the theoretical value. The theoretical value is I is equals to V by R. So I can calculate it. Now I want to measure it practically. What will be my practical value? I should know. What should I do now? What should I do to know the practical value? So what I'll do, I'll take the same circuit, resistor and a battery. Now I'll connect a galvanometer in this. Okay, I'll connect a galvanometer. So why? So we know that galvanometer is a current measuring device. Now this is I. So my galvanometer has its internal resistance G. Okay, the galvanometer has its internal resistance capital G. Now, is the current still the same, guys? So I have connected a voltage. Now I have connected a resistor and a galvanometer. Now now the galvanometer shows some reflections and measures the current. Now, is the galvanometer measuring current? So whatever the current measured by galvanometer, is it correct value? Is it the correct value of current flowing through this circuit? Yes, no, both. See, okay. So we know that galvanometer is a current measuring device, right? So I connected a galvanometer here. Now, when I connected this galvanometer, does this galvanometer measure the accurate current? My question is, does this galvanometer measure the exact current or accurate current? Now try to calculate the current flowing in this. Tell me how much current is it calculating? Yes, obviously no. Thank you, Rahul. Thanks, Rahul, for response. Others, guys, please try to respond. Yeah. So the current, if I try to calculate the current, my current would be I is equals to V by R plus G. Oh my God. See, I try to measure current practically. Now, if I try to measure a current here, it shows that there is some G factor also in this current. Initially, I wanted to measure only I is equals to V by R, but now I'm measuring I is equals to V by R plus G. Now, okay, there is some extra value. So there is some error, inaccurate measurement, right? So this is inaccurate measurement. So how can I make it accurate? How can I make it accurate? Come on, tell me, how can I make it accurate? So this is the scenario given to you. So I want to measure the current. I have connected the galvanometer in series. It didn't show. Yes, G is the resistance of galvanometer. Okay. So G is the resistance of galvanometer. Okay, then I'll try to replace this with an arrow. So this is a galvanometer with the resistance G. So G is the resistance of galvanometer. Now this is the current which is measuring. Now how can I measure the actual current or accurate current? So there is an error in this, right? Now how can I measure the accurate current? Tell me, guys. Okay. So to eliminate, yes, correct, Rakesh. I have to connect a shunt resistance. Okay, shunt resistance. So guys, remember, anything which is connected in parallel was called as shunt. Okay, anything which is connected in parallel is called as shunt. So It's by convention, it's called shunt, so we also call it as shunt. But after the English people who have dominated us, we call it as parallel. But before colonization, everything which was connected in parallel was called as shunt. Okay. So what happens? We connect a shunt resistance across it. So why do we do that? In order to get the accurate value. So to eliminate the error, what I do, we'll connect a shunt resistance across my G such that, okay, let me connect a shunt resistance of, okay, what should be the value of this shunt resistance? Yes, so this galvanometer has a resistance of G, and I have connected a shunt resistance of resistance S. So now same amount of current flows. Now, yeah, so now the value of current can be calculated accurately, right? Now this value of current can be calculated accurately. By how? The combination of galvanometer and shunt resistance. See, what is this combination of galvanometer and shunt resistance called as? So what does this do? How does this work? So when I connected a galvanometer, there was some current flowing through this galvanometer. When I connected a shunt resistance, what happened to the effective resistance? What happens to the effective resistance of galvanometer? Guys, when we connect a resistance in parallel, when we connect resistance in parallel, the effective resistance of parallel network will be much more lesser than the individual resistances, right? So guys, I think we had discussed this while discussing series and parallel. Say if R1, R2, R3 are the different resistors connected in parallel, yes, the resistance, the effective resistance, R effective, will be much more lesser than the least resistance connected, right? The effective resistance of parallel circuit will be lesser than the least resistance. Say if R1 is lesser than R2 is lesser than R3, then R effective will be much more lesser than R1. Okay. So this way, the whatever the resistance of my galvanometer, which was giving an inaccuracy, this can be eliminated by connecting a shunt resistance. So when I connect this shunt resistance, the effective resistance of this circuit will comes to negligible, okay, will be negligible. By making the resistance of the galvanometer resistance negligible, we can find the current flowing through this accurately. Now this combination is called as an ammeter. Okay, this combination is called as an ammeter. Now what is the value of S? Now what is the value of shunt resistance then? What is the value of shunt resistance to be connected? So are you guys getting this? Are you guys getting this? So I wanted to measure the current, so I connected a galvanometer. So when I connected a galvanometer, there was error or inaccuracy in measurement because the galvanometer gave some resistance. So in order to eliminate this error or to eliminate this unnecessary resistance, I introduced a shunt resistance across the galvanometer. Now the effective resistance of galvanometer is decreased to negligible value. Okay, it is decreased to negligible value. Now I can measure the accurate measurement of ammeter. Now what is the value of shunt resistance? Okay, so for that we'll consider an example. For example, if we consider a galvanometer, say a galvanometer can measure maximum range. Its maximum range is 1 milliamperes. Say when 1 milliampere of current flows through the galvanometer, what happens? The galvanometer shows full deflection. So we saw the galvanometer in previous slide, right? So there was this dabba with some readings, and there was 0 here. So there was a needle here, okay, in this arrangement. So when I connect this with a battery, and if I supply 1 milliampere of current, what happens? This shows full deflection. So this needle comes to this point. So such a galvanometer, now I have to convert. So I want to measure the required measurement. The required measurement is 1 ampere. So I want to measure 1 ampere. So what is the shunt resistance to be connected across that galvanometer? Say, how does this work? Now say this is the network of resistance R connected with a battery. Okay, now I connect a galvanometer with shunt resistance. Yes. Now if I consider this, only the galvanometer and shunt resistance. So this looks something similar to this. S and G are the resistance of galvanometer and shunt resistance. Now I is the total current flowing, right? What should happen now ideally? What should happen is, so my galvanometer should take the minimum current of 1 milliamperes. Let us call the galvanometer current as IG, and remaining amount of current should bypass this galvanometer through shunt resistor. Are you guys getting this? So what should happen? Say if I give 1 ampere of current through this, what should happen? Only 1 milliampere of current should pass through galvanometer. Remaining 999 milliamperes of current should pass through the shunt resistance. Okay, this is how an ammeter works. Guys, are you getting this? So I should design my galvanometer in such a way, or I should choose my shunt resistance S in such a way that, so all 999 milliamperes of current goes to this, and only 1 milliamperes of current goes to this. So to calculate this, what should we do? Let us apply KCL. Okay, let us apply. Okay, KCL or KVL? Should we apply KCL or KVL? Guys, please tell me, what should I apply? Should we apply KVL or KCL? Or is there, okay, we'll follow one method. Okay, so we know that in parallel circuit, what is the voltage? Okay, please listen, I'll explain that. Okay, so it will be made in such a way because, say, okay, let's discuss that, Priyanka. Listen. Okay, now what happens? What is the potential across this? So guys, if V1 is the potential drop across this, V2 and V1. If V1 is the potential drop across the galvanometer and the shunt resistance, okay, then the voltage across shunt resistance and galvanometers will be still same, right? It will be still V1. Yes. Now, what will be the value of my V1 across S if I consider only S? So I can write V1 is equals to I, okay, if this is Ig, if Ig amount of current flows to galvanometer, how much amount of current flows to shunt resistance? Please try to answer. So if this is I amount of current passed through this combination, if Ig amount of current flows to galvanometer, how much current will flow to shunt resistance? Please try to answer, guys. Yes. So, and I, so if total current is I and Ig amount of current flows to galvanometer, then the remaining current, that is I minus Ig, should flow through shunt resistance. Now, using Ohm's law, we can say V is equals to I into R, right? So the current flowing through the shunt resistance is I minus Ig into S. Similarly, the V1, voltage V1 will be equals to the galvanometer current Ig into galvanometer resistance G. Now, since V1 is the same potential drop across the combination of galvanometer and shunt resistance, we can equate this. Okay, we can equate this. Now, on equating this, we get, what do we get? Ig into G is equals to I minus Ig into S. From here, we can calculate the value of shunt resistance so such that only 1 milliampere of current will be allowed to pass through galvanometer and 999 milliamperes of current will flow through shunt resistance. Okay, so please try to calculate, guys. I'll give you some 1 minute of time. Everyone, please try to calculate the value of S from here. Okay. Guys, please try to calculate the value of shunt resistance. Come on, guys. Priyanka, please try to answer. I think you will get the answer now. So this is the way we are going to calculate my R shunt resistance. Okay. So yeah, please try to find the value of S, guys. Try to rearrange and find the value of S. Are you guys following? Yes, exactly. So guys, please reply. I don't see any replies from here. Is someone, please someone try to reply. What's the value of S? So guys, come on. Trying to rearrange this, we get S is equals to Ig into G upon I minus Ig. Okay. So this is the equation which is used to calculate the resistance. Yes. Further, okay. So this is the equation which we are going to use to calculate the value of S. Now coming to this, say my galvanometer current is Ig. Okay. So my Ig value is 1 milliamperes and I value is 1 ampere. Please try to find substitute the values of Ig and G. Say G is equals to, okay. Try to find the general expression for S, please. Come on. Whatever the value of G be, please try to find the general expression for S now for these values. Yes. So on substituting, we get S is equals to 1 milliampere into G upon 1 minus 1 milliampere. This will be, so I know 1 ampere is 1000 milliamperes, right? So on substituting, I'll get 1 milliampere into G upon 999 milliamperes. From numerator and denominator, my milliamperes would cut. So the value of S would be G upon 999. So this could be the value of my yes. Okay, yes, Hari Prasad. Even that is possible. So further, this equation can be simplified, guys. So further, this equation can be simplified. S is equals to Ig into G by I minus Ig. Okay, I think this is enough for you. Let us keep this equation. So no need to complicate this. Okay, this is the simplest form you could go for. If you take I by Ig and again it will be a mess. So let this be the equation to calculate your shunt resistance. You guys understood? So this please only revise this equation. Please try to remember this equation. Okay. Simple and by heart equation. Please try to remember this equation. So S is equals to Ig into G by I minus Ig. That is the value of shunt resistance. There will be a direct question for you guys if they ask if it's applicable. Try to remember this. S is equals to Ig into G by I minus Ig. Remember this equation. If they ask a question, you can solve. Okay. Next, we'll check for conversion of galvanometer to voltmeter. Okay, now we have a similar situation. So what's happening here? So guys, one more thing before we're going to this. So I wanted to tell one thing in ammeter. So we always keep the shunt resistance. Okay, so we always keep the shunt resistance in very low value compared to the top our galvanometer value. Okay, so that is the one thing which we have to do. Why do we do that? Because to eliminate any error values. Okay, so to eliminate any error values, try to write the give the shunt resistance of very small value. So we calculate that. Okay. Next, guys, we will come to conversion of galvanometer to voltmeter. So what is a voltmeter, guys? What is an voltmeter? Voltmeter is a device which measures voltage. Okay. So let us consider. Okay, let us check how an voltmeter is constructed now. So let us consider a circuit. Okay. Let R, let V be the voltage connected to this, and let us consider two resistors R and R connected in series. Okay. Yeah. Now, if V is the total voltage, how much is the voltage across the individual resistance? So, if I is the current and V is the voltage, how much amount of voltage is dropped on each individual resistance R and R? Guys, come on, reply. Yes, correct, Nikita. Correct, Prasad. Yeah, voltmeter is a device which measures voltage. Now, if total voltage is V and there is a series resistance connected, so there are two resistors of same value connected. How much is the voltage drop across individual resistors? Guys, please try to respond. ಎಲ್ಲರೂ ಎಷ್ಟಿರುತ್ತಪ್ಪ voltage drop individual resistors ಮೇಲೆ? Yes, it will be exactly. So, guys, I think there was some concept called as voltage divider rule and current divider rule. Have you seen this? Have you gone through that? In your CBSE, you might have learned this voltage divider rule. Do you know this? Guys, this is one important topic, voltage divider rule. So what happens if we have an voltage connected? So if we have some voltage connected in, say if we have n number of resistors connected in series, say R1 is 10 ohm, 20 ohm and 30 ohms. Okay, and I have a single voltage of say 30 volts connected. Now, how much amount of voltage is going to drop across the individual resistors V1, V2, and V3? How much is the voltage drop across 10 ohm resistor, 20 ohm resistor, and 30 ohm resistor? So there was a formula for this, guys. So please note down the formula. V1 will be equals to V into R1 divided by R1 plus R2 plus R3. Okay, this is the formula which we are going to use. So this is nothing but the simplification of your main formula from Ohm's law. Okay. So this is nothing but the simplification from main formula of Ohm's law. So it's nothing but I have applied Ohm's law and simplified this. Okay. I have applied Ohm's law and simplified to this form. Okay. Please make a note of this. Similarly, V2 will be equals to V into R2 divided by summation of all resistors. Okay. Then V3 will be V into R3 divided by summation of all resistors. Okay, this is voltage divider rule. This is a simple formula which can be used to find the voltage across individual resistances. Please make a note of this, guys. This will be helpful for you in your problem solving. Problem solve ಮಾಡಬೇಕಾದ್ರೆ ಈಸಿಯಾಗಿ ಸಾಲ್ವ್ ಆಗುತ್ತೆ. Please ಬರ್ದಿಟ್ಕೊಳ್ಳಿ. Yes. So 30 into 10 by 3, 4, 5, 6. Okay. 30 into 10 by 60. Just start the path. So 30 by 6, 5 volts. 5 volts. So it remain 5 volts. Next up, 30 into 20, 60 by 60. So 30 into 10, sorry, 30 into 20 by 60. 1 volt. 30 into 30 by 60. Okay, V2 10 volts. Huh? Okay, so remaining should be 15 volts. Yes, got this, guys. This is the simplest way. So this is called as voltage divider rule. Okay. This should be done in your CBSE. Please make a note of these equations. ಕೇಳಿಸ್ಕೊಂಡ್ರಾ ಬರ್ಕೊಂಡಿದ್ದೀರಾ guys? Have you listened and written? Okay, I'm going to erase this. Okay, please remember this. Okay, this is voltage divider rule. Similarly, for calculations, so this will simplify your calculations, guys. So unnecessarily you don't have to put Ohm's law and find the total current, then find the total voltage, then find okay. So what you do generally is, yeah, you'll apply to, you'll find the equivalent resistance, then find the voltage, then find the current, then multiply that voltage into current, then find the drop. No need of all such drama. Please try to, yes, please try to derive that. Okay, Hariprasad, I think it's done in your school. Is it done in your school? Yes, there is current divider rule. One next thing is current divider rule. So there is current divider rule also. So if we have any circuit, any parallel circuit, okay. So voltage divider rule is always for a series circuit. Current divider rule is always for a parallel circuit, okay. So if we have n number of resistors connected in parallel, say let me consider 3 resistors connected in parallel. Now I have connected this across a potential voltage source. Yeah, potential difference V. Now if I is the total current, so this I splits into I1, I2 and I3, right? I1, I2 and I3. Now, what is my value of I1? What will be my value of I1? There is a direct formula, that is I1 is equal to I into resistance on other branch. Resistance on other branch divided by total resistance. Say here I have to find the value of I1, I1 alone. I1 is equals to I into, so effective resistance of these two, say R1, R2 and R3, right? So effective resistance of these two, so R2, R3 divided by R2 plus R3 divided by summation of resistance. Summation of resistance would be a current divider rule. Okay, so this will be a current divider rule. So current divider rule is bit like this. If they give instead of two resistors, instead of three resistors, if they give only two resistors, then current divider rule is very easy. Okay, so whenever you get such devices, then okay, you can calculate this very simply easily. For three resistors, it will be a bit difficult, but for two resistors, it will be easy. Okay, so from here you can write I1 will be equal to I into the resistance on other branch R3 divided by R2 plus R3. So this will be a current. Okay, this is the easiest way. So these are the two rules: voltage divider rule and current divider rule. Okay, I hope this is learned by you guys. So if you know all these rules, guys, different rules, you can solve any type of problems in a matter of seconds. Otherwise, you can solve. See, all the questions in KV, I mean, all the questions in current electricity is very simple and very easy. But the only thing it requires is the practice and the proper tools. Otherwise, it will, you will be solving, but it will take lots of time. Okay, so that is the one thing. Okay, so I have not mentioned voltage divider rule and current divider rule here. I try to write separately and give you. Okay, so coming back to this conversion of galvanometer to voltmeter. So let us consider a galvanometer. Okay, let us consider a circuit in such a way that we have two resistors connected in series. From here, what is the voltage across these two resistors? Voltage drop on individual resistors would be, yes, V by 2 and V by 2. Now, this is the theoretical value which I got from voltage divider. Okay, this is the theoretical value I got from, say, voltage divider. Now, if I want to calculate, if I want to measure its action value, what should I do? So what I'll do is, I'll connect a galvanometer. So I'll take the same circuit, and what I'll do is, I'll connect a galvanometer across. Guys, remember, always whenever we measure voltage, we connect in parallel. Okay, because in parallel circuits, the voltage remains constant. Okay, so what should be the value which should be measured by this galvanometer? So again, this galvanometer will have a resistance of G. Okay, so what will be the value of voltage measured by this galvanometer? So guys, if you remember, the galvanometer also has some resistance, right? The galvanometer also has some resistance, and this resistors, these two combination is connected in parallel. What will be my effective resistance now? Say, what will be my effective resistance now? If I call the effective resistance as R dash, so if I call these effective resistance as R dash, what will be it? So that will be R into G by R plus G, right? So again, this will be much more lesser than R dash will be much more lesser than R. So my voltage drop also decreases. See what happens? So since my R is lesser, what will happen to the voltage drop? By voltage divider rule, if we apply, so these divider rules can be applied to loops also. That is the reason we are given. We can apply anywhere. In any circuit, we can apply. Okay. Cool. So yeah, coming back, we can apply. Priyanka. Okay. So again, given that, yeah, these two resistors, okay, the resistance of these two, effective resistance of these two resistors is much more lesser. What happens? The voltage drops. So there is an error. Again, there is an error in the measurement of voltage. Error in measurement. So how to eliminate this error? There is error in measurement, right? So how to eliminate this error? So how can I restore, or see, when I connected these two in parallel, what happened? Their effective resistance reduced. So what happened to the voltage? Voltage also reduced. Now I want to revive it. I want to make it normal. I want to make the resistance back to V by 2 again. So what should I do? So error formula is measured value minus theoretical value upon measured value. Yeah, no, we can't add a shunt resistor here. For galvanometer to voltmeter, what we do is we'll add a series resistor. So what will happen? So when I connect a series resistor here, if I add a series resistor here, what should happen? So let me pick a color. So if I had a series resistor R here, the effective resistance of these increase, and in such a way that if this is much more greater, say I'll call this as R2, if the resistance also of R2 is much more greater than R and G, what happens if R2? If R2 is much greater than R1 and G, or R and G, there was no R1, right? So there was only R. So if the resistance connected in series, if the value of resistor connected in series is much more greater than the resistance which was connected in previously or the galvanometer, then what happens? This will try to minimize. So what happens? What happens to the effective voltage? Sorry, what happens to the effective resistance? This effective resistance R dash will be approximately equals to R. How? So let's check that. So now on connecting a series resistor of high value with G, what happens to R dash? My R dash will be equals to, so G into R, okay, G into, yes. So my R dash will be equals to G into R by, okay, if I try to rearrange this, like this. Okay, if I take this formula G into R by R plus G, so what happens if I take G as common? So I'll be taking G as common, the numerator and denominator, G by G. So what will happen? R by G plus 1. This is the equation we get, right? So G cancels here. Now, if I increase the value of G, what happens to this combination? If I increase the value of G by connecting a series resistor, what happens to this? Priyanka, it should not be a shunt resistance, it should be a series resistance, right? Everyone, while converting a galvanometer to voltmeter, it should be connected in series, not shunt. Okay, so what happens? So if I take this series resistor, this resistance again, so R dash is G into R by R plus G, right? So if I take G common on both numerator and denominator, what will happen? I'll take the G common from numerator and I'll take the G common from denominator also. So what happens? G cancels. The remaining term is R by G plus 1. So if you observe this R by G plus 1, now if I increase the galvanometer resistance, so whatever the galvanometer I have, if I increase its resistance, what will happen to the effective resistance here? This value is negligible. Okay, then my R dash will be approximately equal to R. Okay, this is the way we try to compromise, or this is the way we try to clear the inaccuracy. Okay, so how can we study that? Now let us study that. So what happens? We connected a galvanometer across the series resistance. I mean, there were two resistors connected in series, right? Okay. So initially we had two resistors connected in series across a battery. There was current I and voltage V. Now this series resistors is connected here. Now this combination of galvanometer and resistance. Okay, this I'll call it R2. This combination of galvanometer and resistance is called as a voltmeter. Okay, so my value of R2 is very high. Okay, now we have to increase the now we have to increase the calibration, or we have to increase the range of G. How can we increase it? So by connecting a high value resistance, what happens? Now this high value resistance converts this galvanometer into an voltmeter. Okay, this is the way we have to convert the galvanometer into voltmeter. So again, we'll consider an example again. So again, let us consider an example. In this example, okay, so if I have a galvanometer of range, say, if the VG, so galvanometer is constructed in such a way that the voltage, so it gets the maximum deflection in galvanometer occurs at potential drop. So if I have a potential drop of VG, if at the potential drop of VG, so if I give some VG amount of voltage to this galvanometer shows full deflection. Okay, so this VG is given is nothing but Ig into G, right? So we know that the galvanometer current flowing through the galvanometer is Ig. So VG will be equals to Ig into G. But the required range of galvanometer is V volts. Okay. Now, how to convert this VG to V? So we know that for a very small voltage of VG, my galvanometer shows full deflection, but I have to convert this galvanometer of very small deflection to a required voltage to convert it to a desired range of voltmeter of voltage V. So let us consider only this part of the circuit, okay, where I have my G and R. So let us consider this part. So I have a G, the galvanometer. So let me activate it with this. So the galvanometer resistance is G and the series resistance is R2. Now this is again, and Ig is the current flow through this. Now what will be the value of my V? So Vg is the voltage drop across the galvanometer, and what will be the potential across the VR, or resistance R2. If V is the total potential applied, if V is the total potential applied, say if V is the total potential applied or across this, or V1 is the total potential across this resistance, then the same amount of potential will be also across G and R2, right? So V1 is the total potential and Vg is the potential across galvanometer. How much is here? How much is across R2, guys? So there should be a voltage drop of V1 minus Vg across R2. Okay, if we are going to calculate V1 volts, then there should be a drop of V1 minus Vg across R2. Okay. So in a series circuit, the current flowing is same, right? In series circuit, say we had this G. So we had a galvanometer G connected in series with a resistance R2 and let V be the voltage across this. Okay, yes, let us consider V as a voltage. So if V is the voltage, if V is the total voltage across this galvanometer, now this conversion, so Ig is the current through this, then there will be a potential drop of Vg. There will be a potential drop of Vg across the galvanometer. And the remaining potential drop is V minus Vg. Okay, the remaining potential drop is V minus Vg. Since I is the current flowing through this, so let us consider the current flowing through this I. Then I is given by I is equals to V minus Vg upon R2. So since I is the total current in series current, the current remains constant. I is equals to V minus Vg by R2. Similarly, the current across my galvanometer will be I is equals to Vg upon G. Okay, so this is the voltage across galvanometer, and this is the this is the current across galvanometer, and this is the current across my resistance R2. Now, since they both are having the same amount of current flowing, we can equate this to calculate the value of R2. Okay, we are trying to calculate my value of I resistance R2. So V minus Vg upon R2 will be equals to Vg upon G. Now try to simplify this, guys. Please try to simplify the value. Try to simplify the value for R2. Please try to simplify. So for rearranging, we get R2 by G will be equals to. So I'm cross multiplying. So I'm putting R2 here and Vg here. Okay. So R2 by G is equals to V minus Vg upon Vg. Okay. So this is first step. This is my second step. So R2 by G is equals to V minus Vg upon Vg. Okay. From here, if we try to calculate, what would I get? R2 will be equals to, yes, G into V minus Vg upon Vg. Yes, thank you. Good. Okay, thank you, Hari Prasad. Thank you, Priyanka. Guys, here, if someone tried, try ಮಾಡಿದ್ರೆ solve ಮಾಡಕ್ಕೆ. So further, what happens? So my R2 is equal to G into V minus Vg upon Vg. So what I'll do, I'll try to split this. So this is nothing but G. Okay, let G be here. So let us not take G directly here for now. Let us keep G in the denominator only. R2 by G is equals to V minus Vg by G. Okay, why? I'll tell you. So what happens now? So this will be V by Vg. Okay, some technical errors. Yeah. R2 by G will be equals to V by Vg minus Vg by Vg. So why I did this? To simplify this. So what happens? what happens to this? So my R2 by G will be equals to V by Vg minus 1. So now, what is the value? So if I put the value of G now, what will happen? So this will be R2 is equals to G into V by Vg minus G. Okay, cross multiplying, we'll get this. So if you see, observe this carefully. The G by Vg. Okay, let me try this. The G by Vg. It's not visible. Yes, if you try to check this G by Vg, what is G by Vg, guys? So we know that I is equals to Vg by G, right? Then if I is equals to Vg by G, if I try to write 1 by I, that will be G by Vg, correct? So Ig was Vg by G, then 1 by Ig will be G by Vg. Are you following this? So what happens to my R2? Yes, R2 will be V by Ig minus G. This is my final answer. This is how we calculate the series resistance R2. Okay, this is the value of series resistance R2 to be connected. Got this? There is no response. Guys, please respond. Are you guys able to text me, guys? Please let me know if you are not able to chat with me. Like the other day. Okay, so this is the expression for your R2. Please remember only the final expression. R2 is equal to V by Ig minus G. That's enough. So this is the conversion of galvanometer to voltmeter and galvanometer to ammeter. So next we'll come to Wheatstone bridge. So there is a connection called as Wheatstone bridge. Say, so there is an application for your meter bridge also. Say if I have, so this is the schematic diagram of a Wheatstone bridge. So why do we use a Wheatstone bridge? A Wheatstone bridge is used to find the unknown value of resistance. Say if we have any resistor whose value is unknown, we can try to find the value of that unknown resistance by using a Wheatstone bridge. Okay, so a Wheatstone bridge schematic diagram is shown here, where this the resistance, the standard arm. So the resistance RP, the standard arm, is a variable resistance. Okay, it's a variable resistor. So I can vary its resistance in such a way I can vary its resistance to get a specific value. Okay. Okay. So someone is questioning last side. Please write down. So R2 will be supposed to be by I3 minus G is the formula. Yes, exactly. 100%. Good. Okay, done, Prajwal. I'll be sharing this anyway with to your notes. Please check that later. So yeah, we have come to the Wheatstone bridge. So a Wheatstone bridge is the device or a circuit. It's a circuit which is used to find the value of unknown resistance. If we have an unknown resistance, we can find that value using this Wheatstone bridge. This is the schematic diagram of the Wheatstone bridge. So in this schematic diagram, we have 4 resistors connected in this way, as shown in the diagram. So this resistor, where it shows as a standard arm, is a variable resistor. We can vary its value. So in general, it would be shown with an arrow in this, which shows these resistances variable. And I have an unknown resistor connected across this nodes B and C, and a galvanometer is connected across nodes B and D, and I have connected a potential difference of E across it. Okay. Now the arm AC is called the battery arm. Okay. Please listen this. Now VD is called as the galvanometer arm. Now I can vary. So what happens? How to find the value of unknown resistance? Okay. So to find the value of unknown resistance, what I'll do, I'll vary this resistance R3. I'll start to vary my resistance. Hope many of you might have seen a potentiometer in your school. So not the potentiometer which we have seen. Okay, rheostat. You are familiar with this rheostat? Are you guys familiar with this name rheostat? Yes. So this rheostat is a device. It's a variable resistor. Okay, this is a variable resistor. What happens? So to find the value of unknown resistance, what I do, I'll first connect this unknown resistance according to the schematics. Now I'll start to vary my resistance such that the current I1 will be equals to I3. So I1 should be equals to I3 and I2 equals to I4, or I'll vary my current. So I'll vary my resistance value R3 until the current through galvanometer becomes zero. Okay, this is the way we have to find the value of unknown resistance. Now we can try to find the value of the unknown resistance by applying Kirchhoff's law. So we know how to apply Kirchhoff's law now. So let us apply Kirchhoff's law to the loop ADBA. Please try to apply the Kirchhoff's law to the loop ADBA, guys. Come on. Everyone try to apply Kirchhoff's law to the loop 1 ADBA. Okay, this is my loop. Okay, now if I consider the current is clockwise or anti-clockwise, you can consider clockwise current or anti-clockwise current. It's left to you guys. Yes, exactly. So that's used to change the resistance. Okay, you can use you can assume the direction of current either clockwise or anti-clockwise. Please try to find the value of by applying Kirchhoff's law to the loop ADBA. Okay, please try to apply the Kirchhoff's law to the loop ADBA, guys. Come on. Hope everyone is doing. Okay, let's see that. So on applying Kirchhoff's law to loop ADBA, we get, so what's happening? So let us assume this way. So what happens? So I1 R1. So this is opposite to the direction of current. So minus I1 R1. Now this is in the direction of current. Okay, in the direction of loop which I'm considering. So I1 R1 minus I1 R1 plus I2 R2 plus 0 will be equals to 0. Okay, thank you, Anusha. Nice, very good. Super, awesome. So that is equals to I minus I1 R1 plus 0 plus I2 R2 equals 0. So consider clockwise direction. Yes, sorry, we have considered the clockwise direction. Otherwise, also you should get the same answer. If you consider anti-clockwise also, it will be 0 minus I2 R2 plus I1 R1 equals to 0. So that way I1 R1 will be equals to I2 R2. Okay. Yes, correct. It is correct. It is also correct. Yes, if you go in the anti-clockwise direction, it will be I1 I0. So I'll go in the anti-clockwise direction 0 minus I2 R2 plus I1 R1 equals to 0. Again, you will get the same equation. Okay. So both ways it's correct, guys. Don't worry. Both ways it's correct. So if we try to see, if we try to observe from here, we get the current. So if we try to rearrange, so what will I get? My I1 R1 is equals to I2 R2. From here, if I try to rearrange, I'll get the I1 value of I1 R1 and I2 R2 as I1 by I2 is equals to R1 by R2. Taking the similar terms together, we'll get this equation I1 by R1, sorry, I1 by I2 is equals to R2 by R1. Okay. Next, guys, come on. Similarly, try to apply KVL for the loop CBDC. Please try to apply the KVL for the loop CBDC. Okay. So what will be the equation now? Ready? Come on, guys, please try to answer. What will be the yeah? Okay, I think you require that values. Yeah, this is my value. So I4 R4, yes. So here my IG value will be equals to 0 in both the conditions because I have tried to tune my resistor in such a way that the current flowing will be equals to I1 will be equals to I3 and I2 will be equals to I4. Okay. So by this we get I4 R4 plus 0 minus I3 R3 equals 0. That's correct, Anusha. Thank you very much. That's right. Now from here we can write that from here we can write I3 R3 is equals to I4 R4. Now similarly, if we try to rearrange, we'll get I1 by I. Okay. So guys, since we had written I1 is equals to I3 and I2 is equals to I4, so we have tried to substitute the value here. So we can also rewrite the same equation as I1 R3 equals to I2 R4. Okay, so they have done this. Then try to simplify that later. So we'll get I1 by I2 will be equals to R4 by R3. So we can see that the equation 1 and equation 2 equates the same thing on the left hand side, right? Yes, thank you, Priyanka. Very correct. Very good. Correct answer. Devikarani, thank you. That's correct one. Okay. So we know that I1 is equals to I3 and I4 is equals to I2. Now rewriting I3 as I1 and I4 as I2, we get, yes, from equation 1 we get R2 by R4. Hope you guys got how it was done. Okay. From here we get that R2 by R1 will be equals to R4 by R3. So this is the equation for Wheatstone bridge to calculate the effective resistance of an unknown resistor. Now we know the value of R1, R2 and R3. We have to calculate the value of R4. So this is the value of Wheatstone bridge. My R4 will be equals to R2 by R1 into R3. So this is the way we can try to solve for the this is the way we can try to find the value of an unknown resistance connected. Okay, guys, done. You guys got this? Okay. Yes, R2 by R1 is equals to R4 by R3. This is the Wheatstone bridge formula. So yeah, summarizing, guys, Wheatstone bridge is a circuit which is used to determine the value of an unknown resistance connected. Now, yeah, we'll vary the value of R3 such that my I1 will be equals to I3 and I2 will be equals to I4. Then trying to rearrange, we'll get the equation by applying KVL as by applying KVL to both the loops, we get I1 by I2 is equals to R2 by R1 and I3 by I4 will be equals to R3 by R4. So on substituting the value of I3 equals to I1 and I2 is equals to I4, we get R2 by R1 will be equals to R4 by R3. This is the way we have to substitute. I mean, this by using this equation, we can try to find the value of an unknown resistance. Okay. So we'll try to solve a formula in this case. The given circuit, find the equivalent resistance between A and B. Okay, guys, please try to solve this. What happens? So use the formula of Wheatstone bridge here. So this is my R1, this is my R2, this is my R3, and this is my R3, and this is my R4. Okay, what is the relation we know? R1 by R2. Is it R1 by R2? It's R2 by R1, right? R2 by R1 is equals to R4 by R3. So when we were studying, it was P by Q equals to R by S. Why will we not apply Wheatstone bridge for more or less than 4 resistance? We have other simplifications, Prasad. There is star delta method and other methods which is not taught to you guys. Does anyone know star delta method? star delta and delta star method. So that is the method used to find the effective resistance. So this is one of the method. Okay. So what happens? Other form of checking is, say, guys. Most often people try to forget this. Okay. So try to remember this way. So the value is, so yeah, try to remember this way. So whenever you have 10 ohm, okay, please try to draw a Wheatstone bridge if you forget more often, and check for the opposite ones. Say you remember the x, okay, remember the x symbol, okay. So what happens? First you have to check these two ends, multiply these two ends, then multiply these two ends, 1 1 2 2, multiply these two, then try to equate them. Okay, this is the way you have to check for Wheatstone bridge. So here you have 10 ohm, 6 ohm, 5 ohm and 3 ohm. So we know that 10 threes are 30 and 6 fives are 30, or 10 by 5 is 2 and 6 by 3 is also 2. Okay, since both are equal to 2, the mid resistor, the resistance of 220 ohm can be neglected because there is no current flowing through that. Then the effective resistance looks like 10 and 6 ohm in series and 5 and 3 ohm in series, and their combination is in parallel. So you get 16 ohm parallel with 8 ohm. So 16 into 8 by 16 plus 8, that is, yes, 16 by 3. Okay, so you will get the final answer as 16 by 3. This is your final resistance. You have to find using Wheatstone bridge. Okay. Next question I have. So the four arms of the Wheatstone bridge have the following resistances. AB is 100 ohm, BC is 10 ohm, CD is 5 ohm, and DA is 60 ohm. A galvanometer of 15 ohm resistance is connected across BD. Calculate the current through galvanometer when a potential difference of 10 volts is maintained across AC. Okay, guys. Priyanka, you were asking, right? Can we apply current divider rule here? Yes. Now you can apply current divider rule here. Guys, can you apply current divider rules? This problem can be easily done using current divider rule. Can you do it? Okay, this problem could be done using current divider rule, but since you don't know the value of I, since you don't know the value of I, you are not able to solve it. Okay. But if you knew the value of I, or you can try to solve, okay, you can try to solve using current divider rule, but that would take some time. Okay. So instead, please try to solve using normal method. Please apply KVL to this. To solve this, you have to apply KVL considering the mesh BADB. So 100 I1 plus 15 IG minus 60 I2. So considering this, okay, plus 100 I1 plus 15 IG. This is in the opposite direction, so minus 60 I2 will be equals to 0. Similarly, okay, on simplifying it, will get 20 I1 plus 3 I3 minus 12 I2 equals to 0. So considering the mesh BCDB again, so 10 I1 minus IG. So please consider that. So considering the loop in clockwise direction, 10 into I1 minus IG minus 15 IG minus 5 into I2 plus IG equals 0. On simplifying this, we get 10 I1 minus 30 IG minus 5 I2 equals 0. So I will get the two equations, 20 I1 minus 6 I2 minus I2 equals 0. On simplifying these, so okay, now we have to consider three meshes here, 1, 2, and 3. Third meshes, ADCA. So 60 I2 plus 5 into I2 plus I3 equals 10. So that is 65 I2 plus 5 I equals to 10. Now on simplifying, you'll get this equation. So please try to simplify this, and you'll get the final answer as yes, 4.87 milliamperes. Okay. So guys, yeah, we'll check this. So I think it's time for us to end the class. Um, I was able to complete only up to Wheatstone Bridge. So Meta Bridge is still pending. So guys, other than this, yeah. So, but sometimes I'm getting confusion in the flying of slow. Okay, ma, you can apply. There is no issues. You can apply. So, but you should have proper practice before applying. So, please make a note that to do enough practice. So, guys, coming to this notice. So, there is a notice for everyone, only for the JEE mains applicants. Okay. So, in which case, okay, in a case that such that my R1 will be equals to, okay, say in which case, say if I call this resistance as R1, R2, R3, and R4. So my Ig will be equals to 0 only when my R1 into R3 will be equals to R2 into R4. Only in that case, my value at Ig will be equals to 0. In all other cases, it won't be 0. So coming to the thing, like, yeah, JEE mains, guys, regarding JEE mains, there is an important update to be given. So the update is, say you will be having JEE mains starting from month of February. Okay, till month of May. Just a moment, we'll just check it out. Check it out the actual times of. Uh, okay. So guys, JEE exams will be conducted every month from February to May 2021, and candidates can appear in any any of these exams or all of these exams. Okay, so you can either appear in all of these exams or you can appear in any of the given exams. Okay, so yeah, it's from February 2021 to May 2021. Okay, so that's the official note which we that's the note which we have received from Times of India. So you can apply for February, March, April, May. Okay, February, March, April, May, 4 months. You can appear in all four exams. Yes, you can appear in all four exams, or you can appear in any of the two or any of the three. Best of all, whatever the exams you appear, best of those exams would be considered for calculation of results. Okay, guys, this was the announcement which I wanted to make. Guys, if you have any doubts in any of the concepts which were taught today, please let me know. And regarding this, yeah, the Sunday's class will notify you guys. Okay. Yes. So any doubts you could ask, guys. Otherwise, yeah, you could give the NPS and you may leave. Thank you. Okay, guys. Any doubts? Anyone? You could ask if you have any doubts. Please ask me. So, how many questions need subjects? Okay, board. Okay, what about board exam? So, board exam. There is no information about board exam into us yet. So how many questions in each subject? CBSE had given us the previous year's guidelines as 25 multiple choice questions and 5 integer type questions. We will be having 25 multiple choice and 5 integer types. So this 25 multiple choice may have negative marking. I mean, will have negative marking. Multiple choice questions will have negative marking. Integer type questions will not have any multiple. Will not have any negative marking. Okay, so that's much of it. So about your CBSE exams, unaware of it yet. Any other doubts, guys? Registration, when registration starts, we'll notify Prasad. So registration is yet to happen, and there is no official notice yet. So when we get the official notice, we will inform you. Okay. Okay, cool. So guys, if you have any doubts, please let me know, or you could give them this. Yes, guys. Everyone in here, please let me know if you have any doubts. And we'll be notifying you about the class schedule. If there is any class schedule on Sundays, we will notify you that. Okay, we'll keep you updated. Cool. Okay, guys, and we'll meet again on yeah, on if there is a class on Sunday, we'll meet on Sunday. If there is no class on Sunday, then we'll meet again on Monday. Okay. So we have a small part of meter bridge and potential meter to be done. Okay. With that, I think we'll complete our first P17. Which chapter do you prefer to take post this after this chapter? Like after current electricity, which chapter is preferable for you guys? So we are planning to go with modern physics. So modern physics is your atoms, nuclei, and states of atoms, nuclei, matter. Wave nature of particle. Okay, so we are planning to take that because that chapter is easy to understand and has more weightage in the JEE means. Yes. So post after your P17, that is connected electricity, we are conduct the atoms, nuclei chapter. Yes. Atoms, nuclei, and particle nature of and wave nature of matter. Okay, guys, cool. Then we'll wind up our class here, 6:30 plus, and we will meet again on Monday. Thank you.